Oh, okay. I want to talk a little bit about the character controller, adding the character controller to a player capsule, and how you're going to do that, and some of the things to watch out for with the students. So, we have our capsule, and I'm actually going to rename my capsule to player. I would encourage that you tell your students to do the same. Um, so, with this, in order to get the character controller actually on the capsule, we have to add it as a component. So, when I click on the capsule or the player, and you notice the player has the camera as the child still. I just wanted to remind you of that. I'll come down and press Add Component, and just type CH. And the first one that comes up should be Character Controller. Um, when I add that, I'll add the Character Controller component, which is pretty cool. It controls a lot of things, and the two YouTube videos I'm going to direct you to show the class will actually talk about some of these and what they do. And they're actually really powerful. I'm hoping that the students really see the power and enjoyment that they can have with this. Cool thing about the character controller is not only is it just a simple capsule, but for collision purposes, it actually knows what the bottom part of the capsule is, the top part of the capsule, and the mid part of the capsule. So we'll talk about that a lot later, but just so you're aware of what the character controller can do. And the two videos will talk on that a little bit. So once you have the character controller PI class from Mono Behavior is called character controller. Has. And as a reminder, every script is considered a component, and that's how Unity works. So if you think about that component I just added to Unity, the character controller component, it's actually a class written somewhere else that you can access. I'm not going to go and take a look at it. It's huge. And I'm going to call it character controller. If you want to be fancy, this is Unity best practice for private members to have them underscored. Okay, so speed and run speed, those are going to be variables set for character movement. 6 and 12 are good. We can change those if needed. Walk speed is 6. Speed changes. That's why I have a different speed and walk speed. They're going to change dependent on if the character or the player is holding shift for run. Vertical speed is going to be for falling. It's going to be affected by gravity. Next, in this method is called the beginning of the game before anything else happens. And it is only called once. So what it's going to do is set the vert speed to our gravity, which means you have -50 pulling you down. That isn't a quantitative value. That's just something that I played around with until I finally found something that meant it felt like gravity to me. That can be changed, and you're going to want to change it if anyone wants to use a game where the gravity changes. Um, so character controller, so what's going on here is we're setting this variable of character controller, which is of data type character controller, to the component on our actual character that I set. So when I used add component to get the character controller onto our player, this is allowing Unity to access that component. So these two variables change every frame, and they get the last input from your keyboard. Let's take a look at where I got these from because you're going to want to know. So head back into the Visual Studios window. So what this is doing is it's accessing that input manager and looking for the axes, horizontal or vertical, to see if they've been pressed, and then multiplying your speed variable to them. What this does is if it's not being pressed, it's 0, so for vertical. If down is being pressed, it is -1. If up is being pressed, it is 1. And so we're just multiplying the speed to that, so that way when we eventually move our character, it moves by a speed appropriate. Okay, cool. So moving down, this vertical 3-dot movement, so our vector 3 movement is creating a new vector 3 that's going to hold the values for horizontal and vertical inputs that we'll apply later to our movement. Next, this part right here on line 29 is kind of interesting, and you don't have to do it. What this is going to do is it's going to prevent horizontal and vertical movement at the same time going really fast. So you think about a triangle, if you're going to the maximum speed to the right and to the maximum speed forward, and it's going to give you this diagonal, you think of the hypotenuse, you're going to go really, really fast, and in games that's kind of jarring and weird. So since we don't want that, we clamp the magnitude so you can never have your movement in any direction greater than your speed value. Again, you don't have to do this, it's just going to be helpful. Okay, next is jumping. a character controller method called isGrounded, and it's checking to see if the bottom part of that capsule is touching anything. And if it's touching anything, it's going to consider you grounded. And if you are grounded, to prevent double jumping, that's the we then change our vert speed, so we come up here to oh yeah, we're gonna set our vert speed from that -50 from pulling you down to then your jump force. So it goes from -50 to your jump force, which is 15. And so it'll apply a y value to your movement. Same thing with run speed. If you're on the ground, you're allowed to hold shift and change your speed to your run speed. If you're not holding shift, it sets your speed back to your walk speed. Pretty easy. Um, Continuing on with this, okay, this is gonna set if you're not grounded. So if you're not on the ground and not trying to jump, um, it's going to set your vert speed to your gravity. So it's just going to be pulling you down. And it's plus equals, so that way it accelerates. And it's multiplying by time dot delta time, so there's no distortion if your game starts to lag. Then your movement dot y. So if you look up here, movement, y is 0. So we don't evaluate y. Movement dot y is being set to your vert speed. And then again, we multiply all of movement by time dot delta time to prevent any time distortion. So if there's any frame rate delays, it won't affect that. This line of code is kind of interesting. If you don't have this line of code, your character can only go forward, back, and left and right, and they can't go diagonal. So what this does is it translates your vector from global space to local space, and that's just part of the character controller. Then lastly, it tells your character controller to move, and the parameter it accepts is the vector 3, which is movement, and so this will give you the direction you move toward.